We'll study how to prove triangles are similar and corresponding sides of similar triangles are in proportion. Corresponding angles of similar triangles are congruent. So in 9th standard we have studied how to prove two triangles are similar. We know that we are using 3 tests of similarity. Out of these 3 tests we use any one test which is applicable of similarity. A test, Sss test of similarity and Sas test of similarity. We'll take some examples. So here in this triangle ABC, angle B is given 60 degree, angle C is given 45 degree. In triangle PQR, angle Q is given 60 degree, angle R is given 45 degree. I have to prove triangle ABC is congruent to triangle PQR. What I have to prove? Triangle ABC similar triangle PQR. See, how will I prove this? Here I have given 2 angles of one triangle, again corresponding 2 angles of another triangles. I know that angle B is 60 degree, angle Q is again 60 degree, their measures are equal, angles are congruent. Angle C is 45 degree, angle R is also 45 degree, their measures are equal and therefore they are congruent. So how will I proceed for the solution? In triangle ABC and triangle PQR, angle Q is congruent to angle B is congruent to angle Q because B and Q, they are corresponding angles of 2 triangles which are congruent because each 60 degree. Angle C is congruent to angle R, the reason each 45 degree. Therefore, 2 angles of one triangle ABC are congruent to 2 corresponding angles of triangle PQR, and therefore I can say triangle ABC similar triangle PQR. Reason for this is AA test of similarity. So pause the video and write down this. We will solve second example. Here in triangle ABC, PQ is given parallel to BC. PQ is parallel to BC. What I have to prove? Prove that triangle APQ is similar triangle ABC. I know that since this PQ is parallel to BC, if lines are parallel, corresponding angles are congruent. And this angle A is common. So, in triangle APQ and triangle ABC, first one, angle A is congruent to angle A as angle A is common angle. Angle ABC is congruent to angle APQ is congruent to angle ABC. Reason for this is as the sides are congruent, sides are parallel, corresponding angles are congruent, and therefore triangle APQ is similar to triangle ABC since 2 angles of one triangle are congruent to 2 corresponding angles of another triangle, and therefore triangles are similar. AA test of similarity. Pause the video and write down. Example 3. Here we have given triangle ABC. AB is 2, BC is 4 and AC is 3. In this triangle PQR, this one is 3, this one is 6 and this PR is 4.5. Prove that triangle ABC similar triangle PQR. Here all 3 sides of triangle ABC and triangle PQR are given to me. So I will make use of Sss test of similarity. Be careful how to use Sss Test of Similarity. So when three sides of one triangle are in proportion with the three corresponding sides of another triangle. What do you mean by proportion? When the ratios are equal, it is called proportion. So to use Sss Test of Similarity, I have to find out the ratio of corresponding sides. So first I will find out AB upon PQ. How much it is? AB is 2, PQ is 3. So simplify if it is possible. Second one, BC upon QR. How much is BC? BC is 4. How much is QR? QR is 6. If I simplify, again I will get the ratio BC is to QR as 2 upon 3. Third one, AC upon PR. Substitute the value of AC. AC is 3 and this one is 4.5. Be careful, since decimal is there, remove the decimal first. So first I will write this as 3.0, 4.5. I will make decimals equal and then remove decimals. I will get 30 upon 45. If I simplify it, again I am getting 2 upon 3. So from statement number 1, 2 and 3, what I will get? AB upon PQ is equal to BC upon QR is equal to AC upon PR. Reason for this is from statement 1, 2 and 3. With this, what did I prove? AB, BC and AC are the three sides of triangle ABC are in proportion with PQ, QR, PR, which are corresponding sides of triangle PQR, and therefore triangle ABC is similar to triangle PQR. What is the reason? Sss Test of Similarity. Pause the video and write down this. Fourth example. Here, segment AD and segment BC intersect each other at point O such that AO is 1.4, CO is 2.8, OB is 2 and OD is 4. What I have to prove? Triangle AOB is similar to triangle COD. Here only two sides are given, lengths of two sides are given. What did I observe? These two are vertically opposite angles. So even if vertically opposite angles are always congruent. So first I will find out AO upon CO. What is the value of AO? Substituting 1.4. This is 2.8. If I simplify, value is 1 upon 2. Then BO upon DO. This is 2. This one is 4. Again 1 upon 2. So from 1 and 2, what I will get? AO upon CO is equal to BO upon DO. The reason for this is from statement 1 and 2. And I know that angle AOB, this angle, is congruent to angle COD. Reason for this is vertically opposite angles are congruent. So what did I prove? Two sides of one triangle are in proportion with the two corresponding sides of another triangle, and the included angle are congruent, and therefore triangle AOB is similar to triangle COD. Reason for this is Sss Test of Similarity. Pause the video and write down this. Examples. Question number 5. Here quadrilateral PQRS is given trapezium. PQ is parallel to RS. What I have to prove? Triangle POQ is similar to triangle ROS. As we know that if lines are parallel, then corresponding angles are congruent. Alternate angles are also congruent. And interior angles are supplementary. So now here I will consider triangle POQ and triangle ROS, where angle POQ, this angle, is congruent to angle ROS. Reason for this is vertically opposite angles. Then angle OPQ, this angle, is congruent to this angle. They form Z shape, therefore they are alternate angles. So angle OPQ is congruent to angle ORS. So what did I prove? Two angles of this triangle POQ are congruent with two corresponding angles of triangle ROS, and therefore triangle POQ is similar to triangle ROS. Reason AA test of similarity. Now we'll study one more property. Corresponding sides of similar triangles are in proportion. If triangle ABC similar triangle PQR, then we know that AB upon PQ is equal to BC upon QR is equal to AC upon PR. So AB, BC and AC, these are sides of triangle ABC. Corresponding sides PQ, QR and PR, they are in proportion. It means the ratios are equal. Already we have solved examples. So we have solved questions based on corresponding sides of similar triangles are in proportion in 9th standard, as well as chapter number 4, geometrical construction. In triangle, we'll solve one example. Triangle ABC similar triangle DF. AB is given 2.4, BC is given 3.6, AC is given 4.2, D is given 6. Find EF and DF. So here triangle ABC similar triangle DF, this one is given. So what is the relation between their corresponding sides? AB and D, they are corresponding sides. BC corresponding side is EF, AC corresponding side is DF. So all these three sides are in proportion. It means their ratios are equal. AB upon DE is equal to BC upon EF is equal to AC upon DF. Reason, corresponding sides of similar triangles are in proportion. Substituting value, what I will get? AB is 2.4, D is 6, BC is 3.6, EF I have to find out, AC is 4.2, DF I have to find out. So first I will consider these two ratios to find EF. So what I will get? 2.4 upon 6 is equal to 3.6 upon EF. By cross multiplication, 2.4 into EF is equal to 3.6 into 6. So this 2.4 I will transfer to this side, it will become divided by. Removing decimals, what I will get? 36 into 6 upon 24. 6 ones are, 6 fours are, 4 ones are, 4 nines are. EF is equal to 9 units. Now to find out DF. So I will compare first ratio and the third ratio, that is 2.4 upon 6 is equal to 4.2 upon EF. By cross multiplication and solving, I will get EF is equal to 4.2 into 6 upon 24. Removing the decimal. So be careful while removing the decimals, that is 42 into 6 upon 24. 6 ones are, 6 fours are, 2 twos are, so I will get 21 upon 2, that is 10.5 units. So I will get EF is equal to 10.5 units.